Hello everyone, so this is the derivation of the amortisation formula, which is at the top of page 31 in your log tables. And this is the formula for calculating equal repayments at equal intervals, and note that the repayments are at the end of each interval. It's stated in the log tables for an annual repayment of a principal P over t years with I equal to the annual rate of interest. Now, it can be used to calculate a monthly repayment of a principal P where t is the time in months and I is the monthly interest rate. So as long as they all tie in with each other, A, T and I, if they're all the correct unit of time, then you're fine to use this formula. Okay, so the idea is you get out a loan of P and you want to repay a fixed amount at the end of each time period. Let's assume it's years, but just bear in mind it can be done for months. Okay, so you get out P here today. Okay, and then you're going to repay by an amount A at the end of each time period for T time periods. Okay, so we've got a timeline here, and this is 1, 2, up as far as T years. This is T minus 1. So you're repaying A at the end of the first year, you're repaying A at the end of the second year, at the end of the T minus first year, and at the end of the T year. Okay, and you want all the current values of those A's when added together to equal the principal that you get out on the first day. Okay, so what we're looking for here is present value. Present value. Okay, so the present value of amount A year from now is A divided by 1 plus I to the power of the number of years that have passed by to bring you to this point. So we need to go back by 1 year, so this is to the power of 1s, which we don't need to write. Okay, and then the second A here, its present value is A divided by 1 plus I to the power of 2. We need to drag it back 2 years to get it to present day value, and the formula I'm using there is present value is future divided by 1 plus I to the power of t. Okay, and then this A out here, we need to drag that back by t minus 1 years to get it to present day. So it's A divided by 1 plus I to the power of t minus 1. And this here is A divided by 1 plus I to the power of t. Okay, and we want to add together each of those present values, and they should equal the amount P that we get in a loan today. Okay, so this P here should equal the sum of the present values of all of those future payments. Okay, so what we have here on the right-hand side of the equation is a geometric series with the first term, little a, using notation from the log tables, equal to A over 1 plus I. The common ratio or equal to 1 over 1 plus I, because we multiply each term by 1 over 1 plus I to get the next term. And then n, the number of terms, is equal to this value up here, t. There are t terms in that sum. Okay, so P should equal the sum of a geometric series, which is the first term A over 1 plus I times 1 minus r to the power of the number of terms, which is t in this instance here, all over 1 minus r, 1 over 1 plus I. Okay. And then it's a case of manipulating the formula. Notice here in the formula given in the log tables, you have A on its own on one side. Okay, so we want to get A on its own. Okay, so P here is equal to, let's do some work on the numerator and the denominator. So we have here A over 1 plus I, and then on the inside I'm going to get a common denominator of 1 plus I to the power of t. So the first term 1 is 1 plus I to the power of t over 1 plus I to the power of t, minus, and then we have 1 to the power of t. So just to note, this here is 1 to the power of t over 1 plus I to the power of t, and 1 to the power of t is just 1. Okay, so all I did there in the numerator was get a common denominator inside the brackets, and then in the denominator I'm going to get a common denominator of 1 plus I. So that's 1 plus I minus 1. Okay, so P is equal to, so in the numerator there, you have A times 1 plus I to the power of t minus A. Actually, I'd rather not multiply that through. So I have A over 1 plus I times 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. And then I'm going to invert and multiply the denominator. So I get 1 plus I all over, so here 1 plus I minus 1 is just I. Okay. And therefore on the right hand side there, that 1 plus I cancels with that 1 plus I. Okay, Then I'm going to multiply across by the denominator of 1 plus I to the power of t times I to get p times I times 1 plus I to the power of t equal to a times 1 plus I to the power of t minus 1. And then I'm going to divide across by this here so that we get a on its own on one side. So p times I times 1 plus I to the power of t divided by 1 plus I to the power of t minus 1 equal to a. And that is the formula on the top of page 31 of your log tables. That's the derivation of the amortization formula.